用热烈的掌声欢迎 the laureate of Nobel Prize in Physics and the Turing Award, Professor Jeffrey Hinton, and the director of Shanghai Artificial Intelligence Lab, Professor Zhou Bowen, to have a pinnacle, cutting-edge dialogue. Please, the floor is yours.
Thank you, Professor Gu. Thank you very much. It's truly a pleasure for all of us to have you here in person, Jeff.
Thank you.
Thank you very much. So I want to start a question that you shed some light early this week, but you did not have time to talk about it on stage this morning, which is about subjective experiences of multimodal language models. So you believe that you can prove even today's multimodal language models could develop their own subjective experiences. Can you elaborate more on this?
So I think the problem with issues of whether they have consciousness or subjective experience or awareness is not strictly a scientific issue. It's an issue of what you mean by subjective experience, or consciousness. So most of us have a model that I believe is deeply wrong. So most people aren't aware that you can use words correctly and you can have a theory of how the words work that's completely wrong, even for everyday words. So what I would like to do is give you an example of everyday words where you have a theory of how they work and they seem like straightforward words and your theory is wrong. So, and I need to do that so you accept the idea that you can have a wrong theory of how what a word really means. So think of the words horizontal and vertical. Most people think they know what they mean by horizontal and vertical, but they have an incorrect theory. And I will prove to you have an incorrect theory by asking a question that people nearly always get wrong. You might get it right, but people nearly always get it wrong. So suppose I have in my hand a lot of little aluminium rods, and they're in all sorts of orientations, and there's thousands of them. And I throw them up in the air, and they tumble and turn and bump into each other, and suddenly I freeze time. And so there's all these aluminium rods in the air. And the question is, are there more that are within 1 degree of vertical, or more that are within 1 degree of horizontal, or is it about the same? And almost everybody says, well, it's about the same, because of their theory of how the words work. And they're wrong by a factor of more than 100. Actually, for these little aluminium rods, there's about 114 times as many that are within 1 degree of horizontal as there are within 1 degree of vertical. And that's because that's vertical, and this is vertical, but that's it. And this is horizontal, and this is horizontal, but these are horizontal too. So horizontal, there's many more horizontal rods than there are vertical rods. Vertical is very special. And the question is, why don't people know that? Why don't people know vertical is very special and horizontal is very common? So here's another question. I have a handful of discs, little aluminium discs, and they're all random orientations, and I throw them up in the air, and they tumble and turn, and I suddenly freeze time. Are there more that are within 1 degree of vertical, or more that are within 1 degree of horizontal, or is it about the same? And the answer there is, there's about 114 times as many that are within 1 degree of vertical. And that's because for a disk, or a plane, that's horizontal, and this is horizontal, but that's it. This is vertical, and this is vertical, and this is vertical. So, in 3 dimensions, vertical rods are very special, and horizontal rods are very common, but horizontal planes are very special, and vertical planes are very common. And when you form your theory of the word, you sort of average over those. So you think horizontal and vertical are about the same, but that's completely wrong. It depends on whether you're talking about lines or planes. For lines, vertical is very special. For planes, horizontal is very special. And people don't know that. And because they don't know that, they give the wrong answers to these questions. Now, that may seem irrelevant to the issue of consciousness, but it's not. It says that we can have a theory of how words work, and in this case, the theory is that vertical and horizontal are equally special. That theory is completely wrong. It depends whether you're talking about lines or rods, lines or planes. For lines, vertical is very special. For planes, horizontal is very special. Most people don't understand that, so they have a wrong theory of how the words work, and they give the wrong answers to these problems. Now, my view is almost everybody has a completely wrong theory of how terms like subjective experience work. They have a very strong and completely wrong theory. And so it's not really a scientific problem. It's a problem of starting with a wrong model of what mental states are and how these terms we use to describe mental states work. And with the wrong model, I think you make the wrong predictions. So my view is current multimodal chatbots are already conscious.
So this may sound alarming to many of the researchers in the audience, but let me tell you what just heard from another Canadian scientist earlier at this conference, Richard Sarden, he just gave a talk earlier before you, talking about the welcome to the era of experiences. So I think his intention was that models can learn a lot when we exhaust human data by now, can learn from its own experiences. So you shed some light on another angle that the agent or multimodal LLMs not only learn from experience, they can develop their own subjective experiences. Yeah. So I think Richard didn't touch much today about the potential risk of this learning from subjective experiences. Do you want to say more about that? The fact or your theory or your hypothesis by this point that the agent can learn subjective experiences pose any potential risks down the road?
Yes, it's certainly the case that at present, the large language models, for example, have learned from documents we feed them. They learn to predict the next word a person would say. But as soon as you have agents that are in the world, like robots, they can learn from their own experiences, and they will, I think, eventually learn much more than us. And I think they will have experiences, but experiences are not things. An experience isn't like a photograph. An experience is a relationship between you and an object.
So also, a couple of days ago, when we discussed about the potential risks at ADAS, you mentioned one possible solution to reduce the future AI risk is find a way to train separate objectives of AI. For example, one kind AI, one smart AI. You have a theory that...
I didn't mean that. I meant you'll have an AI that's both smart and kind.
Yes.
But the issue of how you train it to be smart and how you train it to be kind are different issues. So you can have techniques for making it kind and techniques for making it smart, and it'll be the same AI, but there'll be different techniques. And so countries can share the techniques for making it kind, even if they're not willing to share the techniques for making it smart.
So I have some doubts about, I mean, the idea is well-intentioned. I really like that idea. But I have some doubt about how far can we go on this, because do you think there's going to be some universal training AI to be kind method can be applied to any level of AI models of various levels of intelligence?
That's my hope. It may not be true, but that's a possibility, and I think we should investigate that possibility.
Yeah, indeed. But I want to make an analogy here to just, I mean, I raise this question, it's not that I don't like this idea. I raise this question, I want to raise awareness so more people can do more research on the direction you mentioned. I want to make this analogy that why I have this doubt is because we take physics as an example. So when the object moves at a much lower speed, Newton's law works. But when this object moves into higher speed, close to lighter speed, Newton's law doesn't work. So we have to go to Einstein for better solutions. Oh, by the way, you know, this is very ironic. I'm talking this physics 101 to a Nobel Prize winner in physics.
But that was a mistake.
No, we AI people believe this is not a mistake. You well deserve that Nobel Prize.
They really wanted to give a Nobel Prize in AI, and they didn't have one, so they took the physics one and gave it in AI.
Yeah, but I'm using that analogy to make a point that I think the kindness constraints probably need to be changed for different levels of intelligent systems. I don't know if that's true, but I do help younger people who are smart in this room or online can figure out a way to make this happen.
Yes, it's quite possible that as the system gets more intelligent, the techniques for making it kind will change. We don't know, and that's one of the reasons we need a lot of research on it now.
Well, many people was very impressed by that. You, Jeff, as such a well-achieved individual, you often say, I don't know, I don't know. You know, I think that's very, very honest and keep open-minded. I think that's something we all need to learn from you. So in addition to AI questions, we have half of the room come from different scientific fields. They're like a top-notch scientists in quantum physics, biology, cell research, and so on and so forth. So the reason why we gathered together today, because we believe there are endless frontiers happening today, either on HCI side or on the AI side, or at the intersection point where AI can help advance science. Yes. So that's why we gathered together. So we have this forum of people talking about this. So I was wondering, what do you want to say about using AI to improve science, or vice versa, using science to help advance next generation AI?
So I think it's very clear that AI is going to help science a lot. Obviously, the most impressive example so far is protein folding, where Demis Hassabis and John Jumper and others showed that using AI sensibly and putting in a lot of effort, it took them 5 years, and they're very smart people, you could do much better at predicting how proteins will fold. I think that's a sort of early marker that says that in many, many areas now, AI is going to improve science. You mentioned the example, I think, of predicting where a typhoon would land.
Yes.
And predicting the weather in general. AI can do a bit better than the best systems.
The best system in physics.
Yes.
We use a large model to do much better than traditional TDE systems.
Yes.
Okay. So, Jeff, throughout your outstanding academic career, you have not only pushed the boundaries of AI technologies, but also profoundly influenced the next generation of scientific researchers. I talked to Yang, I talked to Joshua, and many, many younger generation than you. They all admire your mentorship on them. So here at the Shanghai AI Lab, I want to share with you our leader researchers' average age was around 30 years old, 30. So a clear sign that the future of AI belongs to the young generation. So looking at these people, young faces here, so I was wondering, anything you want to share with them? Anything on your mind? What's the next chapter for AGI? Or any advices you think you can give to them, help them grow faster? And anything they can take home, they can tell their parents. And I think you might have a few fans today that tell you they're going to tell their kids they met you today. Right. So anything they can tell their parents, that's what I learned from Jeff today.
So I have, I guess, just one piece of advice, which is if you want to do really original research, you should look for somewhere where you think everybody's doing it wrong. And normally, when you think everybody's doing it wrong, you start investigating your way of doing it, which you think is going to be better, and eventually you realize why everybody's doing it like that, and your way turns out to be wrong. But you shouldn't give up on your way of doing it until you yourself understand why it's wrong. You shouldn't give up on it just because your advisor says that's a stupid approach. Ignore your advisor. Keep going with what you believe in until you yourself understand why it's wrong. And just occasionally, you'll keep going with what you believe in, and it won't be wrong. And that's where big advances come from. But they don't come from people who give up easily. You have to stick with it even when other people don't agree with you. Now, there's a piece of logic that supports this approach, which is either you have good intuitions or you have bad intuitions. If you have good intuitions, you should obviously stick with your intuitions. If you have bad intuitions, it doesn't really matter what you do, so you should stick with your intuitions.
Thank you very much. I know we can... I can appreciate the appreciation towards you. So I think we can continue this dialogue for the whole day, but I know you are tired. So I think last I will ask each and every one of you joining me, thank Jeff for his wonderful time with us. Thank you very much.
Thank you.
Thank you so much, Professor Hinton, and thank you too, Professor Zhou, for your very thoughtful, insightful dialogue. So thank you again.